Unit 7 is on polynomials. So for 7.1, we're going to start off with some vocabulary. So a polynomial is an expression made with constants, variables, and exponents, which are combined using addition, subtraction, and multiplication or division. But all exponents are positive. So they're zero or they're positive numbers, and there is no division of our variables. So we have some examples and non-examples. So looking at something like 7x squared minus 9x plus 5, that's a polynomial. You've seen things like this before. We've called them expressions in the past. Non-examples, notice that 9 times x to the negative fifth is not a polynomial because of the negative exponent, and 7 divided by x plus 8 is not a polynomial because it has that division of a variable. So these are our polynomials. So the terms of a polynomial are each individual part that is being added or subtracted. So looking at 7x squared minus 9x plus 5, this has three terms. It has three terms because 7x squared is a term, negative 9x is a term, and positive 5 is a term. The coefficient of polynomials is the number in front of each variable term. So looking at this expression, 2 is a coefficient because that's being multiplied by x to the fourth. Negative 1 is a coefficient because that's being multiplied by x to the third. Positive 3 is a coefficient because that's being multiplied by x squared. And then this negative 6, since it does not have a variable, this is something that we call a constant. Now, when we're looking at an expression altogether, here are the different vocabulary we will be using. So the leading coefficient of a polynomial is the coefficient of the term with the highest degree or exponent. So looking at our problem up here in the corner, 7x minus 9x squared plus 10x to the fifth, well, our highest exponent is this 5, which means that our leading coefficient would be 10, because that's the number being multiplied by the term with the highest exponent. So 10 would be our leading coefficient. Degree of the term, that's the exponent of each term. So 7x has a degree of 1, negative 9x squared has a degree of 2, and 10x to the fifth has a degree of 5. Degree of the overall polynomial is the highest exponent that you see in the problem. So looking at this problem, since 5 is the highest exponent, that would be the degree of our polynomial. Standard form of a polynomial is where we put terms in order by their degree, in other words, by their exponent from highest to lowest. Note that this has absolutely nothing to do with the coefficients, the number in front. It's just looking at the exponents. So looking at the exponents, 5 is our largest exponent, so that would be our first term. 2 is our second largest. Notice how this is a negative 9x squared, so I have to write negative 9x squared. And then 7x has a 1 as an exponent. So from highest to smallest, that would be 5, and then 2, and then 1 as our exponents. And that's how you put something in standard form. You put it in order from highest exponent to lowest exponent. Now looking at this problem, notice how once it is in standard form, so this is standard form, which we'll talk about a lot. Once it is in standard form, notice that the leading coefficient, or the term in the very front, is 10. And that's where we really get this name of leading coefficient from. So these are our kind of general vocabulary. We'll use these a lot when we're talking about polynomials. Now, to get more specific, we can talk about polynomials by their degree. So depending on the degree, 0 through 5 or higher, we have a different name for them. So if we have a degree of 0, we call that a constant, because if you think about something having a degree of 0, right, anything to the 0 power is really just 1. So a degree of 0 is where you don't have a variable. In other words, we just have a number, right? So 6 is a constant. It's just a number. That's our degree 0. First degree we call linear, and so that's what we spent most of our first semester looking at. So something like 4x would be linear because it's got that exponent of 1. Quadratic, we're going to spend a lot of unit or semester 2 looking at quadratics. That's if you have something like 3x squared. All right, it's that second degree, which makes it a quadratic. Cubic, if we had something to the third degree, so if we had like 17x cubed, that would be to the third degree, or cubic we would call it. If we had something to the fourth degree, that would be x to the 4th to the 5th degree, that would be x to the 5th power. Notice how we have special names for 0 through 3rd degree, but then 4th, 5th, or higher, we just say 4th degree, 5th degree, 10th degree, etc. The other way we can talk about these polynomials is by the number of terms they have. So if you have one term, you're called a monomial. So mon is all by itself. So if we had something like 4x squared, that's one term, so that'd be a monomial. A binomial, if we think of a bicycle, right? A bicycle has 2 wheels. A binomial has 2 terms. So 4x cubed minus 10, right? That's got 2 terms. That's a binomial. A trinomial, say we had x to the 5th plus x minus 17. Well, trinomial, 1, 2, 3 terms. Quadnomial, okay, quadnomial, notice that quadnomial is 4 terms, which is different than quadratic, so keep that in mind. Quadnomial is our 4 terms, so we could have something like x to the 4th minus 3x to the 3rd minus x squared plus 10. That has 4 terms, that would be a quadnomial. And then 5 terms or higher, we just say 5th nomial, 6th nomial, etc. Now, things to remember, or ways to help you remember it. Monomial, right? Mon means 1, that root word. Binomial, think of a bicycle with 2 wheels. Trinomial, think of a tricycle with 3 wheels. Now, last thing we're going to do is we're just going to practice using all this vocabulary. So we're going to look at a couple of these polynomials, and then we're going to let you practice a couple on your own. So standard form, remember that's putting our exponents from highest to smallest. So looking at 5 minus 2x, well, our negative 2x would go first, and our constant always goes at the end. 100% of the time, if there is a constant, it should be the last thing. The leading coefficient then is this negative 2. The degree of the polynomial, well, this is x to the 1st power, so we would have a degree of 1. And looking back at our vocabulary, we call a degree of 1 linear. So name by degree would be linear, and name by term, this has 2 terms, 1 term, 2 terms, and so this would be a binomial. So we're just practicing using our vocabs. We'll do a couple more together. If we have 3x to the 4th minus 4 plus 2x squared, well, standard form would be 3x to the 4th plus 2x squared minus 4, highest exponent to lowest exponent. The leading coefficient, once it's in standard form, is 3. The degree of the polynomial would be the highest degree, so that would be 4. And again, you can look back at those to help you with the vocabulary. Well, 4th degree, we just call 4th degree, pretty easy to remember. 4th degree, and then since it says 3 terms, this would be a trinomial. So we would call this a 4th degree trinomial. I'm going to have you go ahead and practice the other ones on your own. We'll do negative 12 really fast. Your negative 12, notice that it's all by itself. The leading coefficient doesn't really have one. You could say it doesn't have one, or negative 12. I would accept either. The degree would be 0 because it doesn't have a variable in it. Name by degree, well, since it's just a number, we would call this a constant, and then there's only 1 term, so it would be a monomial. So, monomial. So looking at these, we're really just practicing using that vocabulary. Now, start memorizing the vocabulary. We'll be having a quiz on that coming up pretty soon here. And again, you just want to practice that vocabulary.